Okay, this is over electron configuration. There are 3 guiding principles for electron configuration. The first rule is Aufbau, and it means to build up. You start at hydrogen always. Hund's rule tells us we got to fill each box first before doubling. And Pauli's exclusion principle says opposites attract. We represent our electrons with arrows. So we're going to get started on our first one, which is boron. And our atomic mass, we want to round that to a whole number, so 10.8 rounds to 11. For the group, I go to my periodic table, and it is right here. And that family is called the boron family. That's why you need your periodic tables. I look to see where it's at on the periodic table, and I notice it's right here on the stair-step line. That makes this a metalloid. Now I look to find out what the atomic number is. That says 5. That also means I have 5 electrons. Now I take the difference between the atomic mass and the protons. 11 minus 5 is 6. Valence electrons, if it's marked on your periodic table, makes it super easy. We have 3 here. And to draw my structure, I simply do the letter, and I put 3 dots around it. 1, 2, 3. Okay. Now on to electron configuration. I go to my handy dandy periodic table, and I'm going to see that boron is here. If I look across, and if these were numbered, this would be row number 2. So boron is on row 2. It is in the P block, and it's 1 in. So 2p1 is my endpoint. Okay, so I go to 2p1, I put in 1 electron. Now, since the only way I can get there is I got to go through everything else below it, these are going to be filled. And so my electron configuration is 1s2, 2s2, 2p1. And now if I take this and I go 2 plus 1, that equals 5, which is the proton count. Okay, let's try the squares. So on the squares, these are a little bit more challenging because we'll throw the transition metals in, but let's start off the same way. So first thing up, atomic mass rounded. That should round to 55. Group family, I'm going to go find manganese. Manganese is right here on the periodic table. So that's transition metals. And the name gives it away. It's a metal because it is to the left of the stair-step line. Protons, there's my atomic number. That's 25. Electrons are also 25. I take the difference between 25 and 55, and I'm going to get 30. Okay, you notice there's no Lewis dot and there's no valence electrons because transition metals have more than one charge associated with them. Okay, so now let's go find our endpoint. So if I read my periodic table, here's manganese. I go across the row and it says 4. But I've got to remember that I was supposed to mark this, with a 3, a 4, a 5, and a 6. And my intertransition metals go up 2 levels from the row they're on, a 4 and a 5. So even though this is on the 4th row, since it's in the D block, its energy level is actually a 3. So this is 3D, 1, 2, 3, 4, 5. So 3D5. Again, I always want to find my endpoint first. So now I'm going to put in 5 electrons. 1, 2, 3, 4, and I'm following Hund's rule. I put 1 in every single block first. And now onto alpha bound and Pauli exclusion principle, I have to go through all the other boxes below it in order to be filled. And I can put a max at 2 and an up and a down. It must be. So these are all filled down below. And so my electron configuration will be 1s2, 2s2, 2p6. I got to put all my 3's together, so I'm going to do 3s2, 3p6, and then I've got to jump to that 3d5. And now I can write my 4s2. So even though I had to go through the 4s block to get to the 3d5, when I write it formally, I have to put all the 3's together, and it's always s, p, d, and f order, sorry. And if I check myself, 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 5 is 25. So I've got my count. And that's called a longhand. And you were expected to do longhand. So now I'm going to throw in something else with this. So there's also a shorthand way of writing things. And the way this works is I look at what row I'm on, and I'm going to go up to the noble gas above it. So here I'm on row 4, and I'm going to go up to row 3. And row 3's noble gas is argon. Okay? So I want to draw a line right here on my chart. This represents argon's electron configuration, everything below that line, because it's the last filled p shell. And so for shorthand, I simply write AR, and I'm going to write everything above it in order. 3d5, 4s2. And that's how I do electron configuration. Now, academic, you're expected to do the circles and the squares. Honors, you also have the stars, and I'll be addressing that in a different clip. Thank you for your time.